Hey, everybody, welcome back to class. This is my good intro.
Yo, what's up, guys?
Yo, what's up, guys? Don't forget to subscribe and make sure you turn on your notifications. And...
Hit the like button. Hit the like button.
Hit the like.
Anyway, so folks playing along at home, hit the pause button, do these two problems, and then we'll go over them here. Okay. All right. So let's go over these two problems, and then just to kind of run down this week again, so I can say it on video again. Section 6.3, we're finishing up we did section 6.3 yesterday. We're finishing up the first part of chapter 6 today with section 6.4. Tomorrow we'll be working on the practice test. Tomorrow's a work day on the practice test. That means on Thursday we will be going over the practice test, and then we have our test in here on Friday. You will get your exam review on Friday. It will be due on Monday and Tuesday. We will review Monday, Tuesday, Wednesday, exam on Thursday and Friday of next week. So that test on Friday is like your last chance to raise your grade if you need to before the exam. Also, don't forget all ornaments are due on Monday. So make sure you do that if you'd like to. The paper is up online on my calendar. I know I introduced it on a video. I forget what video, but I did introduce it on a video. I think it was the one on the 6-1, 6-2 quiz day. Yeah. But I did introduce it on a video. So if you want to go back and watch that, you can do so. But all ornaments are due on Monday. If you want to turn them in early, some people have been turning them in early. I will put the grade in like whenever you turn it in, so that your grade can bump up. Okay. All right, let's take a look at each one of these. Solve by elimination. Remember, we learned elimination. You got to have the same number but opposite signs, and then add vertically, right? Add vertically. Okay, so that means that I want to get either x's or y's to be the same value. Now, in this case, I've got to multiply both of them. There's no equation that I can just multiply one by to make it look like the other. Like I can't multiply 2 by anything to make it look like 3. I can't multiply 4 by anything to make it look like 5. So I know that this is a case where I multiply both equations. All right, well, if that's the case, I don't care whether I eliminate with x's or eliminate with y's. It doesn't matter. I'm going to have to do the same amount of work either way. Let's eliminate with y's. Why not? Why not? Why not? What number can I make both of these pretty easily? 20. Now, what number could I have gone with here? 6, right? Well, I guess I should ask this. What did you guys eliminate with? Did you guys get the x's to match or the y's to match? I'm hearing some people say x's. I hear a lot more people saying x's than they do y's. So I guess I should do that, because I guess that would be what you guys would do. That would mean I would multiply the top equation by 3. Now, to get them to be true opposites, I need to make one of them negative. So the top equation becomes a 6x plus 12y is equal to negative 12 when I distribute in. The bottom becomes a negative 6x minus 10y is equal to positive 6. So I've got a 2y is equal to negative 6, and I divide by 2. Y is negative 3. I plug that back in, and I go, let's go to the top equation. Doesn't really matter. 2x plus 4 times negative 3 is negative 4, so 2x minus 12. I add the 12. 2x is 8, so x is 4. 4 comma negative 3 should be my solution. What's up?
So you should never get like a decimal, right?
Have we gotten a decimal ever?
No.
No.
Like,
The only time you would ever get a decimal is for a word problem.
last night I was
Yeah, you know you goofed if you got a decimal. Yeah.
Is this supposed to come out the same thing as the other one?
Yes.
What I do?
Here, let me read your mind and see what you did.
No, wait.
Get my crazy binoculars and see your work right there. Well, read it to me. What did you do?
I
What?
did the Y.
Right, I know, but what did you do?
I did exactly what you did.
Right there?
No, like with the other numbers though.
Okay, so what did you multiply the top by?
5,
What'd you multiply the bottom by?
-4,
Okay, what'd you get in the top?
10, and then plus 21, and then -20.
Okay, what'd you get in the bottom?
-12, wait, no, I lied to you. It's minus, wait, what? -20y equals 12.
Okay, you're good so far.
And then
What'd you get?
-2,
Equals?
-32.
Well, there's your problem. -20 plus 12 is -8.
Oh.
Yeah. And now, to that point, when I see mistakes, it's usually like oh, geez, why did I do that? It's like a sign mistake. Oh, I forgot to carry through. Oh, I added wrong. Oh, whoops, I forgot to multiply in. That's usually the case. That's usually the case. All right, let's take a look at 19. Oh, sorry, Jake, you had a question too.
No.
He did the same thing as me.
Okay. Let's take a look at 19. So, what do I want to eliminate with? What do I want to eliminate with? Do I want to eliminate with X's or Y's?
Y. Y.
Yeah, the second one. Who said Y? Who says X? Oh, it's like 50-50.
You can do Y. You do Y. You do the X and plus the Y. You do
No.
X and Y.
I'll do Y.
Let's go.
Okay, so the top I'm going to multiply by 7, and the bottom by -2. I get one of them's got to be negative. Okay. So the top becomes 35x, 14y, -7. The bottom becomes -6x, minus 14y, -22. Okay, that gives me a 29x and a -29. Divide by 29, x is -1. Plug it back in. 3 times, I'll go into the bottom, doesn't matter. -3 plus 7y is 11. I add the 3, divide by 7, y is 2. -1, +2. Did I get any decimals?
I did.
Well, then you did something wrong. You got to go back and check your work, folks. You have to get that skill. That's not something I can teach you, and that's not something that I'm going to like. I don't know. That's not something that I can teach you. I guess I could stop there. You have to figure out how you are making your mistakes. I can't read minds for everybody. I can't know how I can think how you're going to make a mistake, and I can try to advise you against that. But you have to, if you get a decimal, you've got to go through your work and find your mistake. Okay? You have to. Well, I mean, I guess you don't have to. You get the problem, but if you want to get the problem right, you have to go in and find your mistakes. You have to learn that skill. All right, questions? Questions on those two? Okay, so here's the key for this. Okay, check your answers. I think I went over like 3 of them in second period, so we could go over any of these that we want to. Doesn't matter. I even have the ones that you didn't have to do up there. If you want to write those in, you can do those later. Those turned out to be decimal. I took off 4, 8, and 12, and 4 and 12 turned out to be a decimal. True? Yeah. Now, did you get either of them right?
I got 4.
You got 4? Then check the work for plugging it back in. Because that's a note to everybody. If you get one of the 2 coordinates right, that means that you probably got your first one right, the one that you did first. Now your error is just plugging the other one in correctly. Okay? That's usually the case. Because if you get both of them, if you get the first one wrong, you're definitely getting the second one wrong. Yeah. Yeah. Okay. Drew, I will go over that one if you need to, but check your work there and see if you can. Okay, so what did you solve with? You get the x's cancel, the y's cancel.
The X
Okay, what'd you multiply the top by?
2.
Bottom?
-5.
Good. Read me your top equation.
10x minus 4y equals -96.
Good. Bottom?
-10x minus 15y equals 100.
Let me just double check that number. 23 times 5. You said positive 115?
Yeah.
Good. And then you added down. Did you get negative 19y is equal to, let's see, negative 96 plus 115?
Oh, I wrote x instead of y.
Oh, that would be an issue because y should be negative 1. Y should be negative 1. Yeah.
Can you go over the
Yeah. What did you multiply by?
-2.
To the top?
Yeah.
Okay, read me what you got.
-2y plus 2x equals -34.
Okay, so that's good. And then we take the original bottom. And then read me what you got when you added them together.
5x is equal to -45.
Okay, and so x is going to be what?
-9.
Okay, so you're good with the first coordinate. So your problem is just plugging it in. Which one did you go into, top or bottom?
The top.
Okay, so y minus a -9. I'm guessing that's where we made our mistake.
Well, no, the mistake I made was I plugged it into the multiplied equation. I didn't go back and multiply it into the original.
It doesn't matter. You should get the same thing. -2y plus 2 times -9 is 17. You should have gotten -2y minus 18 is equal to 17. And then we add the 18. Ooh, something's weird here. Hold on a second.
Robert and I were making mistakes.
Oh, it's not, that's why, it's not 17, it's -34. Sorry, I wrote it down wrong. So I add the 18 over to the other side. -34 plus 18 would have gotten me -16. And I divide by -2 to get 8.
I got 15.
Yeah, I don't know what you did wrong. You'll have to look at your own one for that. What other questions do we want to look through? Let's talk through. Yeah, let me go back here. If anybody wants to see any of those answers again. Again, for those of you playing along at home, check your answers. If you got one wrong, you need to go back and figure out what you did, just like we're doing in class here. Yeah. What other questions? Okay, so Riley bought 3 bagels and 2 muffins for $7.25. $7.25. Karen got 5 bagels and 4 muffins for $13.25. The best route to take here is to multiply the top by -2, which would have got me a -6x minus 4y is equal to, and then we got 725 times 2, or -2 in this case, so -14.5. Rewrite the original. And so that gets me a -1x is equal to I have a -14.5 plus 13.25. And that gets me a -1.25. So I get the negative out of the way, it's a positive 1.25. I plug that back into my original. 3 times 1 1/4 plus 2y. So 3.75 plus 2y. Okay, so 7.25 minus 3.75 gets me 3.5. And I divide by 2. 1.75. So that means bagels cost $1.25, muffins cost $1.70. Okay, so let's talk about the next section here, section 6.4. Now, what we're going to be doing with this next section, with this final section, Really, we're not learning anything new today. We are just kind of reviewing the three methods of solving systems, and then kind of applying it to one new scenario. Let me ask you this question. Visually, how do we tell a solution to a system? Like, if I'm looking at the graph, how do I pick out the solution to a system? It's where the two lines, right, where they meet, where they cross, right? Okay. Do all lines cross? So what happens then, right? That's what we're going to be looking at today. We're going to be reviewing all three methods and also figuring out, okay, what happens when we have parallel lines? What does that look like when I try to solve it by substitution or elimination? Okay? So what I just said here, lesson 6.1, we saw that when two lines intersect, there's exactly one solution. When the two lines in a system do not intersect, there are no ordered pairs that satisfy, so therefore there is no solution. Let me show you an example here. Now, I hope you would all agree with me that this one is set up for substitution. Okay? Did I tell you how to solve? No. Could I solve by graphing? Yeah, that's why there's a graph there for you as well if you wanted to do it. We're going to look at it, how it looks like, what it looks like on the graph in a second. But I could solve by graphing. I could solve by substitution. I could solve by elimination. But I want to review substitution. Why is this one set up for substitution? Y is by itself. So that means if y is by itself, I can plug that into y. Okay. I can take it from one equation and plug it into the other. So my equation 2 was negative x plus y equals 3. So I plug in that x minus 4. Okay, what happens in my equation? Yeah, and what do I get when I do that? Yeah, that cancels, doesn't it? The negative x plus x completely cancels out the x, leaving me with a negative 4 is equal to positive 3. Is that a true statement? No. See, this is what's going to happen when you have a set of parallel lines. When you try to solve it by substitution or elimination, you get a false statement. So you can say that there are no solutions. Remember, that symbol means no solutions. You don't need to write it out if you want to just use the symbol. Either one of those are acceptable. Okay? All right, well, let's take a look here and see what would have happened on the graph. Let's just review solving by graphing. Well, the top one has a slope of 1. The y-intercept is negative 4. So we start down here at negative 4. Some of you need a review of graphing. It's really embarrassing how many of you don't know how to graph a line. I don't know how you've gotten to December of your freshman year without knowing how to graph a line. You should have learned that in like 7th grade. All right, so let's go down here. Y-intercept is negative 4. Your slope is 1. Rise 1, run 1. Or down 1, left 1. There's my line. Now, that's line 1. Let's look at line 2. Now, line 2, I need to do some prep work. Negative x plus y is equal to 3. I need to add the x. I need to get it solved for y. So y is equal to x plus 3. Slope of 1, y-intercept of 3. So I go here, y-intercept of 3, and slope of 1. What do I notice about my line? They're parallel, right? How could I have known that just from looking at the equation that they were going to be parallel? What did you notice about the slopes? But about the slopes? Right, yeah, but about the slopes. What are the slopes of each line? They're 1. Remember, two lines that have the same slope are parallel to one another, right? So we should have seen it right from here. Slope of 1, slope of 1. Boom, I can go straight to saying that there are no solutions. Okay? As long as the slope is the same, I'm going to have no solutions. Well, I guess if the y slopes and the y-intercepts are the same, then it could change things. then in that case, if the slopes and the y-intercepts are the same, the lines may be the exact same equation. They may be called what's known as coinciding lines. You might have an infinite solutions rather than a no solution. So let's take a look at our next example. Now guys, again, I would hope, it doesn't tell you how to solve, but I would hope we would try to do substitution. Because this is set up for substitution. So I'm going to show you substitution in graphing. This is set up for substitution. So what I'm going to do is plug 3x plus 2. I'm going to go right in for y. Because it's already solved for y. Y is completely alone already. So I remove y out of the second equation. And I say 3x minus y plus 2 is 0. Three x minus something plus 2 is equal to 0. And now I plug in the 3x plus 2. That goes in for y into the second equation. Remember, this is substitution. Yeah, question.
Why is it like?
Because I need to distribute the negative.
Okay.
So this is 3x minus 2 plus 2. So what do we notice that happens on the left side? Everything cancels. The 3x cancels. The 2 cancels. Those go away. I'm going to end up with a 0 is equal to 0. Is that a true statement?
Yeah.
So therefore, I know that it's not a no solution, but we would call this an all real numbers. Or if you wanted to write infinite solutions. Okay. We could say either all real numbers or infinite solutions. Now, if there are infinite solutions, we know that the lines, what are called coincide, they lie right on top of one another. Look here, my first equation is a y equals 3x plus 2. Let's get the graph up here. Let's graph it. Because let's see what it looks like on a graph. So this first line, the slope is 3, the y-intercept is 2. Right? So I go y-intercept of 2, slope is rise 3, run 1, or down 3, left 1. So you look at these points that I'm drawing. Here's my line. Take a look at my other line. Now I've got to do some prep work again. 3x minus y plus 2. The best route to take to try to get y alone is just to get it over to the other side in this case. But look at my equation. Look at that. What do you notice? It's the exact same thing. Slope is 3, y-intercept is 2. I'm graphing it on the exact same line. That is what it looks like when there's an infinite solution. Because think about it. The solution is where the two lines will cross. So if there's infinite solution, it's going to cross at all places. Okay? It's going to share all those common points. All right, questions about that? Okay, let's take a look at the back. Okay, now, to tell how many solutions it's going to have, okay, to see if it's going to have any solutions, okay, what you can do is figure out the slope and the y-intercept. This is why there's a little bit of room up on top. If there is no solution, okay, if there is no solution, the m's are going to be the same. The slopes are going to be the same. But the y-intercepts are going to be different. Okay, the slopes are going to be the same, but the y-intercepts are going to be different if there is no solution. If there's infinite solutions, meaning coinciding lines, the slopes are going to be the same and the y-intercepts are going to be the same. It's going to look like the exact same equation. The slopes are going to be the same and the y-intercepts are going to be the same. If there is just one solution, the slopes are just not going to be the same. I don't really care what's happening with my b-values. Okay? So no solution, the slopes are going to be the same, but the y-intercepts are going to be different. For infinite solutions, the slopes are going to be the same, but the y-intercepts are also going to be the same. The one solution, if I just have different slopes, I'm going to have a crossing point. Okay, so let's see how I work with this. I've got to figure out the slopes and the y-intercept. Let's look at equation 1. Well, equation 1 says 3y is equal to x plus 3. How do I figure out what my slope is? What do I have to do? I got to get y alone, right? How do I get y alone? Yeah, I got to get 3 over to the other side. And now everybody gets divided by 3. So that means y is equal to 1/3 x plus 1. What's my slope out of that line? What's my y-intercept? Okay, now equation 2 looks like this. Well, if I just add 1/3 x over to the other side, I'm going to be able to solve that for y. Slope is 1/3. B is 1. What does that tell you about these two equations? Infinite solutions. Same slope, same y-intercept, same exact line. Infinite solutions. In the book, when it asks you to classify in the homework, you don't need to classify. Just tell me whether there's going to be infinite or no solutions or one solution. Let's take a look at the next one. We've got x plus y is equal to 5. 4 plus y is equal to negative x. So let's take equation 1 and solve for y. Well, that would mean I would just subtract x to both sides. Okay, so slope is negative 1, b is positive 5. I take equation 2, do that exact same thing. 4 plus y is equal to negative x, so I just subtract the 4 over to the other side. So y is equal to negative x minus 4. Okay. Slopes are the same. Are the y-intercepts the same?
No.
No. The b-values are different. So what's that mean? No solution. These lines are parallel. Okay, let's take a look at the last problem. Excuse me. Let's take a look at equation 1. I distribute in the 4. So the slope is 4 and the y-intercept is 4. Equation 2. I just add the 3 over to the other side. Okay, y is equal to x plus 3. Slope is 1. I don't even really care about what my y-intercept is. Because if the slopes are not the same, how many solutions does it have? One solution. Okay. Does that make sense? So when the problem asks you to give the number of solutions, I'm asking you to just figure out what the slope of the y-intercept are. Notice it's different from my first two examples where I just said, like, find the solution or just solve those, right? Okay. So,
Get this one tonight?
Yes, please.
you want to?
Yes. Yes. Yes.
Who say yes? Okay. Now, I will let you know right ahead of time. You are not allowed to skip exam review.
Oh.
No. Don't complain about it. You are not allowed to skip exam review. That is too valuable.
Take attendance.
Video's still running.
I think it's today.